Hi, everybody. Happy Friday. Congratulations. You made it through week 1 of e-learning. Just 5 more days next week. Oh, but hopefully it's getting easier for you. Hopefully you're understanding how to manage your classes. I do appreciate you guys all tuning in to play Quizlet Live. Scott was like low-key pumped to be playing with you guys and so competitive. So we'll play, I think, GimKit today. That should be a good time. I might have Scott tune in, I might not. But if it's math questions, he's actually really good at math, much to my dismay. So he might tune into play. All right, so yesterday we looked at how to graph a single inequality in a coordinate plane. Today we're looking at how to graph systems. Okay, so we've done systems of equations and we solved it by substitution, by graphing, by elimination. Now you're going to be graphing 2 inequalities and you're going to be shading. Now this is kind of difficult to not be doing in person because normally if we were in class, I'd have you guys using 2 different colors. It was really easy, but hopefully through looking through Smart Notebook right now, it'll help you. And again, if you have questions, pause the video, replay, or just message me. Okay, so Friday agenda. Your goal is to be able to graph a system of inequalities. We're really quickly going to talk about, all right, what's the difference between just a single linear inequality and a system, and what's the difference between a system of equations and a system of inequalities. I'm going to show you how to graph. I'm going to talk about problem solving number 3. I'm going to go through both of them, and then I'll talk about your Friday assignment, and then you guys have the weekend. So here we go. All right, so here's what we're looking at. Now, yesterday we looked at this guy over here. If I gave you one single inequality to graph, you did graph it, and then you learn how to shade it. When we're working with a system, let me move myself off the screen a little bit. Notice that now you have 2 inequalities and you have to shade. So this blue inequality is shaded in blue, the red here is shaded in red, and then the overlap, hopefully you can kind of tell here. Let me grab my highlighter so I can mark it for you. This zone where you can see both colors are blended, this is your solution region. That is what you would mark as your solution because it's encompassed by both inequalities. If you were looking at the difference between a system of equations and system of inequalities, again, with equations, you look for one point in which they cross, that coordinate pair is your solution. However, inequalities, you're looking for a double shaded region as your solution. So a little bit different, but there are similarities. Okay, so let's quickly review from yesterday if we were graphing a single inequality. So this is just review from yesterday. So right now it is in slope-intercept form, so I'm actually good to go and good to graph it as soon as my pen will load. So I'm going to start at my y-intercept of -2, and I'm going to apply my slope of 3. So up 1, 2, 3 over 1, up 1, 2, 3 over 1. Notice that it is a less than or equal to sign. Because it has that or equal to, we are going to utilize a solid line on the graph. And again, not my best, but that's okay. We're going to pretend it's a straight line. To figure out if we are shading above or below, we need to use a tester coordinate pair. Now, because we don't have 0, 0 on our line, we can use that to test in here. So here's your original inequality. Let me move myself. When you plug in 0, 0, here's what you have. And then you need to ask yourself, is 0 less than or equal to -2? So is 0 less than or equal to -2? It is not. It is not. So you need to shade the region that does not include 0, 0. So if I was shading here, I would be shading this whole region because it does not include 0, 0. Okay, because it's not a solution for your inequality. So that should be reviewed from yesterday. Now, as we're moving on, we just talked about this a few minutes ago. The solution region for your system of inequalities is this purple guy here. That's where both colors overlap. That's what's shared among the 2 inequalities. So today, as you're graphing and you're shading your 2, what you're really looking for is, okay, where did the 2 colors come together? Because that's your solution region. So here we go. Let's start kind of graphing one together. Now, you are going to follow the same steps for graphing each one as a single inequality, which is why we just reviewed it a few minutes ago. So if I'm graphing my first one, I'm going to start at -3 because that's my y-intercept. And I'm going to plot my slope of 2. So I go up 1, 2 over 1, up 2 over 1, up 2 over 1, and you could keep going. Because it's just a less than sign, we need to utilize a dashed line. Again, not my best. All right, and then to figure out how we're going to shade, we can plug in 0, 0. So I don't have it written out here on the screen for you, but I bet you guys can do the mental math. So is 0 less than 0 minus 3? Is 0 less than negative 3? The answer is no, it is not. So we need to shade the region that does not include 0, 0, which means it'll be all of this right here. And again, this would be really nice in class if we had colored pencils together, but here we are via computer screen. So we'll make the most of it. All right, for my second inequality, I know I'm going to be starting at 2 because that's my y-intercept. And then I have a slope of negative 2. So I go down 2 over 1, down 2 over 1, down 2 over 1. And this will be another dashed line because it's just a greater than sign. All right, and then there I am. So again, 0, 0 is not on the line, so we can use that coordinate pair to see if we're going to shade a region that includes it or one that does not. So if I plug in 0, 0, again, let's use some mental math. 0 is greater than 0 plus 2. Is 0 greater than 2? No, it is not. So we will shade the region that does not include 0, 0. So now watch for the colors to come together and kind of mix. So I know, just look at the green line. I'm shading this whole region here that doesn't include 0, 0. So let's see if you guys can find where the solution zone will be. Wow. Okay, sorry, I'm doing my best here. All right, so now if I was in class, I would be asking you, what color is the solution region for these inequalities? And you would tell me green, because yellow and blue made green. So this guy right here, that is all that we are concerned about on our inequality. It's this green zone. That's where your colors overlap, and that's your solution region. That's it. All right, let's do another example. Let's come to this one right here. When you are graphing these two inequalities, notice this one is in slope-intercept form, so that one's great. This one is not, it's in standard. So we're gonna have to change that, I know that right away. But let's take care of the orange one because that's easy and we can kind of get that one started right away. All right, so if I'm starting with my orange inequality, I'm starting at 4. 1, 2, 3, 4. And it's a slope of 2, so I'm gonna go up 2 over 1, up 2 over 1, up 2 over 1. It is a less than sign, so we will utilize a dashed line as we're going through. And there I am. Now again, I'm going to keep using 0, 0 because that's a really easy tester pair. So if I'm testing, let me move me over. All right, so here's your original inequality. Plug in 0. Okay, we know this has just become 0. Is 0 less than 4? The answer is yes. So we will shade the region that includes 0, 0. So we will be shading this entire region down here because it includes 0, 0. Hopefully you're speeding through this part of the video as I'm just highlighting my life away here. Okay, now for my blue equation, or sorry, my inequality. It is in standard form right now, so we need to change it into slope-intercept. So here's my original. Okay, 2x minus y is less than or equal to 4. Remember, we want y isolated on the left side here, so I need to move my 2x term to the other side. When I do that, here's what I have. I've got negative y is less than or equal to negative 2x, because we had to move it using subtraction, plus 4. Don't forget, you guys, right here, because you had minus y, you have to keep the minus sign in front of the y because it's applying the negative. Now, we can't just have it being negative y. It has to just be a straight variable, it has to be positive. Therefore, we will divide every single piece of our inequality by negative 1. But hopefully that's kind of a clue in your mind. You're like, uh-oh, I'm dividing by a negative. I'm going to have to change my sign around. So when you do that, here's what you have. You've got y is greater than or equal to 2x minus 4. All right, so now let's go graph that. Now you're good to go. Now you're in slope-intercept form. All right, so I'm starting at negative 4. 1, 2, 3, 4. And I'm going to apply my slope of 2. So I go up 2 over 1, up 2 over 1, up 2 over 1. And this one will actually be a solid line because it's greater than or equal to. So here I am. All right, now let's plug in our tester pair. Again, let's keep using 0, 0. That's super easy. So here's my original inequality. When you plug in 0 for here, for y, and for x, you get 0 is greater than or equal to -4. That is true. It is greater than or equal to -4. So we're going to shade the region that includes the coordinate pair 0, 0. Now let's go grab our highlighter. Oops, sorry. All right, so here's my blue inequality. That's all I'm focusing on. I'm shading the region that includes 0, 0. So I'm shading all the way above. Now, if I asked you, what is the solution of this system of inequalities, you would tell me that it's this green zone here. Those are the shaded portions of the graph that are shared by both inequalities. Only the coordinate pairs in this region here make both inequalities true. Okay, so if you were to shade on your graph, you would only need to shade this middle portion because it's shared by both. All right, I think that's pretty much it. Hopefully you guys kind of got it after these two examples. If you feel like you need some more support or an additional example, feel free to message me, or you guys can watch other videos online. I also have one more video or one more example prepared if you need me to post a video for you on Monday, because we're just going to really cover the skill one more time on Monday because this is pretty important. Okay, so now we are going to we're going to switch gears into problem solving number 3. I'm going to go over the 2 questions. The first one, you guys really knocked that one out of the park. You guys did a great job. I think almost every single person got it correct. This is the one about the computer. It was starting at $598 on sale for 25% off. If Mr. Patel wanted to pay it with a 6-month payment plan, how much would each monthly payment be? So really quick, 2 different things you could do. Here's what I saw most people use, this strategy. They did 0.25 times 598 to show that, all right, 149.5 or 50 is 25% of 598. But then you need to subtract that away so that your discounted price is 448.5. Okay, now if you didn't do this step here, you could also say, if it's 25% off, how much are you technically paying? Technically, you're paying for 75% of that product. So you could have just done 0.75 times 598, and that would have also given you this answer here. Either one works. Now that you know your discounted price is 448.5, well, $448.50. That was my bad. I should have had a 0 here. We can divide that by 6, and we get our monthly payment is $74.75. Most of you guys used a really formal writing style, and I appreciated that. Some of you really need to consolidate your thoughts into a more formal paragraph or, stream of sentences. Okay, number 2. I think a majority of us got 6 out of 8 points on Schoology for this one. Most of us understood the first 3, but I'm still going to talk about it. So if you want, you can fast forward through this if you got these right. It was mainly the last few that we need to talk about. Okay, when you're looking at this graph, it has a bunch of different line segments on here. It is a line segment because if you look, it has the points at both ends. Before I did anything, like when I solved this, I was like, oh my gosh, I have to look at all these line segments. I went onto my graph and I annotated and I said, all right, I know that AC from here to here, it goes up 3/6. So its slope would be 3/6 or 1/2. For BC, it goes up 1/2. So it's just 1/2. For B to D, it goes up 2/4, so 2/4, which is the same as 1/2. It also talks about just this entire line as a whole. What would the slope of that be? So because it's just a line, it goes up 1/2, up 1/2, up 1/2. So the slope of just line T is 1/2. So if this were me, I annotated this on the side because it's going to make our lives easier when we come down this way. So let's take a look. It says the slope of AC is equal to BC. Is 1/2 equal to 1/2? Hopefully your answer is yes. So this is correct. The slope of AC is equal to BD. So AC is 1/2, BD is 1/2. Again, that is true. AC equal to the slope of line T. So AC is 1/2, line T is 1/2. That is also true. Now let's talk about these last 3 because this is something new and I'm not sure that we've seen it. There were about 2 or 3 of you that got it correct. So good job for you. All right, let's transition. When it is talking about just EC, and that's not saying like the slope of anything, It's talking about the length of the line segment. So for EC here, E to C, it is 6 boxes across. So EC is 6. Its length is 6. For AE, it is 1, 2, 3 units here. So you would click 3. Okay, and then I did the same thing for FB and the same thing for FD. So it says the slope of line T, which we know is 1/2, is equal to EC over AE. Well, EC is 6. Let me get my pen. So it's going to be 6 over AE is 3. Well, I know that 6 over 3 is 2. Is 1/2 equal to 2? No, so that is not correct. Then it says the slope of line T is equal to FB over FD. Well, FB is 2 over FD is 4. 2 over 4 is 1/2, so those are equal. So E would be correct. Then it says slope of line T is equal to AE over FD. Well, 3 over 4 does not equal 1/2, so that one does not work. That is false. So only E would have been selected here. So if you got that, congratulations. But now hopefully if you see this in the future, you know what's going on. Okay, really close to being done, I promise. Your homework tonight, just for your Friday, is T6 on IXL. Make sure that you guys are doing the correct one. It is T6. I've seen some weird things, you guys are choosing different ones. It is T6, my friends. You need to get to a SMART score of 80 before you can stop. So let's talk about how to do that on IXL because it's a little bit different. Okay, notice T6 right here, solving systems of linear inequalities. All right, so here's what you need to do. It tells you to graph these two, and you can use different colors down here. So let's say that I'm starting with the first one. Y is less than or equal to -1. Because it's just the y and the 1, I know that it's actually going to be a horizontal line, which makes our lives kind of easier. So it's less than or equal to -1. And because it's less than or equal to, we'll use a solid line. So there it is. When I come to my purple guy here, it's saying x is less than or equal to 5. So I come where x is 5, put a dot. That will also be a solid line. When you want to shade, you click the shade button, but the challenge is you can only shade your solution region. You saw me using the 2 different colors, and then I'm like, ooh, where they overlap, that's the solution. But you have to think ahead, so you only shade the solution region. So watch how I do it. I know that it's going to be y is less than or equal to -1. So if I was shading, it would be this whole zone here. And I know that it's going to be x is less than or equal to 5. So it'd be all of this zone here. The only part that's shared is this little guy here. That's the only part. So once you've got that, you scroll down, submit. Yay, I got it right. Okay, let's try again. So it says y is greater than -5. So go where y is -5. And it shouldn't be solid, it should be dashed. And then let's do our second inequality. It says x is greater than or equal to -1. So find where x is -1. Let's do our line, and it should be solid. Okay, now to shade. Ask yourself, if y is greater than -5, that means that this whole region up here above my purple line will be shaded. And if x is greater than or equal to -1, this whole region will be shaded. The only part that is shared is this zone here, okay? And that's essentially how it looks. All right, my friends, if you need me, I am available to you via computer screen. You guys have blown it out of the park this week. You have done so well. So get T6 done. Next week, you'll have an next round of problem solving. Pretty much same thing every day, video assignment. If you need me, I'm here for you. Much love. Miss you guys. See ya.